We've all felt it, right? Time just keeps marching on, unstoppable. Every second ticks by, pushing us into the future. But what if that forward march isn't endless? What if time itself has an expiration date? What if, one day, time just stops? To wrap our heads around this, we first need to understand what time really is. We often think of it as a river, flowing from past to future. But in physics, time isn't a thing in itself, it's a measurement of change. Think about it. A clock works because its hands move. The Earth's rotation gives us days because its position changes relative to the sun. If nothing in the universe changed, could you even say time was passing? You couldn't. No change means no time. And here's the unsettling part. The universe is slowly, but surely, running out of change. Everything that happens, from the smallest particle vibration to the grand collision of galaxies, needs energy. Stars shine by burning through their fuel. Planets orbit because of gravitational energy. Even our own thoughts are powered by tiny electrical signals in our brain. Energy is the engine of change. It's what makes the cosmic clock tick. But just like the fuel in your car, the universe's energy supply isn't infinite. Every star that burns, every reaction that occurs, is using up a finite resource. And once that energy is used, it can't be perfectly reused. It gets spread out, becoming less useful, less concentrated. This brings us to a fundamental law of the universe, entropy. You might have heard of it as a measure of disorder or randomness. A simple way to think about it is that everything tends to move from a state of order to disorder. A hot cup of coffee doesn't stay hot forever. Its heat spreads out into the cooler room until everything is the same temperature. An ice sculpture doesn't just sit there. It melts into a puddle. Entropy always increases. Over cosmic timescales, this means the universe is relentlessly moving towards a state of maximum equilibrium. All the concentrated pockets of energy, like stars, are spreading their energy out into the vast, cold emptiness of space. So, what happens when this process reaches its conclusion? Scientists call it the heat death of the universe. It's a scenario that plays out over trillions upon trillions of years, far beyond any time scale we can truly comprehend. First, all the stars will burn out, one by one, leaving behind a sea of cold, dead remnants like white dwarfs and neutron stars. The galaxies themselves will eventually fall apart. Even the supermassive black holes at their centers, which seem eternal, are predicted to slowly evaporate over unimaginable lengths of time through a process called Hawking radiation. Eventually, even protons might decay, meaning the very matter we're made of could dissolve into basic particles and radiation. The universe will become a cold, dark, and perfectly uniform soup of diluted energy and particles, just barely above absolute zero. In this future, what happens to time? With no stars to burn, no planets to orbit, and no matter to interact, the universe becomes static. Change grinds to a halt. There are no more events. Nothing happens. A clock in this universe wouldn't tick because there's no energy to power it. And even if it could, what would it be measuring? Without cause and effect, without one thing leading to another, the very concept of a moment loses its meaning. Time, as a measure of change, becomes irrelevant because there is nothing left to change. But it's important to understand this isn't like hitting a pause button. Time doesn't just freeze in a dramatic instant. Instead, it would likely stretch out, becoming infinitely slow. The gap between one event and the next would grow longer and longer until, eventually, there are no next events. It's not a sudden stop, but a gentle, eternal fade to nothingness. Imagine a film slowing down until a single frame lasts for an eternity. That's the end of time, a state where nothing happens, forever. Now, could anything prevent this? Physicists are always exploring alternatives. Some theories propose that random quantum fluctuations could, after an eternity, spontaneously create a new Big Bang, resetting the cosmos. Others speculate about a big crunch, where gravity pulls everything back together, or even the existence of other universes in a larger multiverse. But for our universe, based on what we currently observe, the arrow of time points firmly in one direction, towards increasing entropy and eventual heat death. The trend is clear. So, what does the end of time really mean? It's an end so complete that there's no one left to witness it. No observers, no consciousness, no memories. Without events, there is no past to remember or future to anticipate. Time is a property of a dynamic universe. It only exists when something is happening. The story of the cosmos is written in change. And when the final page is turned, and the last change occurs, the story ends. The universe never promised us it would last forever. In a way, the time we have is borrowed. It's a fleeting property of a universe that is still young and full of energy and change. But one day, that change will cease. And when nothing happens anymore, time itself will quietly and completely disappear. Thanks for watching.